Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have a semicircle, this is a semicircle. In addition, you know that line segment AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM is equal to X according to what is given us in the question. So we know that AOB is a quarter circle, therefore this angle AOB must be equal to 90 degrees. It is a right angle. And also side AO and side OB are equal to each other. They are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10 units according to what is given as the equation, therefore OB must be also equal to 10 units. It is also the radius of this quarter circle. So the radius of the quarter circle equals to 10 units in its length. But OB that is equal to 10 units, it is not only the radius of the quarter circle, but it is also the diameter of this semicircle. Okay, the diameter of this semicircle is OB, and it is equal to 10 units in its length. We define the center of this semicircle, this point is P. Therefore, the radius OP must be equal to 10 over 2, that is 5. PB also is the radius of the semicircle, therefore it is equal to 5 units in its length. We define the point of tendency of tangent AM with this semicircle, this point as Q. And we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. We have the radius PQ of the semicircle that is drawn to point Q, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. We focus at the point A. Point A is the common external point in relation to this semicircle. On the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ, and according to rule number 2, they are equal to each other. So AO equals to AQ, but AO equals to 10 units, therefore AQ must be also equal to 10 units in its length. Again, according to rule number 2. In the next step, we extend line segment AM and line segment OB by side line until they touch each other. This point is their touching point. We define their touching point as N. By doing this construction, we added here the right big triangle, triangle AON. In the right big triangle AON, we define this angle as theta. We continue to focus on the right big triangle AON. In the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle, the right green triangle, triangle QPN. In the right green triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta, according to the same logic. In the next step, we will prove that the right big triangle AON is similar to the green triangle QPN. So I write it down. We prove that the right big triangle AON is similar to the green triangle, triangle QPN. So why those two triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle AON. And it is equal to this angle in the green triangle PQN, it is angle PQN. Repeat again. Angle AON in the big right triangle AON equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. If we relate to angle theta as it belongs to the big right triangle AON, it will be defined as angle ANO, and it is equal to itself. If we define angle theta as it belongs to the green triangle QPN, it will be defined as angle QNP. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. It is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle NAO, the big triangle ANO. And it is equals to this angle, this is actually angle QPN, the green triangle. Repeat again. Angle NAO in the big right triangle ANO equals to angle QPN in the green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the triangles in the big right triangle AON are correspondingly equal to all the triangles of the green triangle, triangle PQN. Therefore we proved that those two right triangles are similar to each other according to angle similarity rule. So I will write it down. We proved actually that the big right triangle AON is similar, this is the sign of similar, to the small red triangle, triangle QPN, according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AO in the big triangle AON or side QP in the green triangle equals to side AN in the big triangle AON over side PN in the green triangle. Repeat again, we derive that side AO in the big triangle AON over side QP in the green triangle equals to side AN in the big triangle AON over side PN in the green triangle, and it is also equals to side ON in the big right triangle AON over side QN in the green triangle. Okay, so actually found out that AO over QP equals to AN over PN equals to ON over QN. AO is 10 over QP is 5, and it is equals to AN. What is the length of AN? From the drawing it is very easy to see that AN equals to AQ plus QN. That is to say AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. If AN equals to 10 plus QN, divided by PN. PN, from the drawing it is very easy to see that PN equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. Here, PN equals to 5 plus BN, and it is equal to ON. ON, from the drawing it is very easy to see that ON equals to OP plus PB plus BN. So ON equals to OP, that is 5, plus PB, that is 5, plus BN. So ON in total equals to 5 plus 5, that is 10, plus BN. So in total ON equals to 10 plus BN. Here ON equals to 10 plus BN divided by QN. QN is the missing sign, so we leave it as it is. Here 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN. And it is also equals to 10 plus BN over QN. Those two sides are equal to each other, therefore we create equation number 1 from those two sides that are equal to each other. So according to equation number 1, we get that 2 equals to 10 plus QN over 5 plus BN again, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. Those two sides are also equal to each other, therefore we get equation number 2 from those two sides that are equal to each other. So according to equation number 2, 2 equals to 10 plus BN over QN. Again, according to equation number 2, we found out that 2 equals to 10 plus BN over QN. Here we we'll multiply this equation number 1 by 5 plus bn. And we get that according to this equation number 1, two times 5 plus bn equals to 10 plus qn. Here we'll open the brackets on this side of equation number 1, this equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times bn is 2bn, is equals to 10 plus qn. So here we have 10 on both sides of the equation, so 10 will get cancelled, and we're left only with qn that is equal to 2 times bn. This is to say qn is twice as long as bn, according to equation number 1. Here we have according to equation number 2, 2 equals to 10 plus bn over qn. Here we multiply this equation number 2 by qn. And we get that according to this equation number 2, two times qn equals to 10 plus bn. Again, according to equation number 2, 2 times qn equals to 10 plus bn. But we already found out that according to equation number 1, qn equals to 2 times bn. Therefore, we can substitute qn in this equation number 2 by 2 times bn. We do it now and we get that according to equation number 2, 2 times qn, and qn is 2 times bn, that is equal to 10 plus bn. So here we have 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. Here we subtract bn from this equation number 2, and we get that according to equation number 2, 4bn minus bn is 3bn, that is equals to 10. Here we divide this equation number 2 by 3, and finally we get that bn equals to 10 over 3. bn equals to 10 over 3 units in its length, according to equation number 2. So here we write down that this line segment bn equals to 10 over 3 units in its length. According to equation number 1, we have already found out that qn equals to 2 times bn. So qn equals to 2 times bn, and bn is 10 over 3. bn is 10 over 3. So qn equals to 2 times 10 over 3 is 20 over 3. So we found out that according to equation number 1, qn equals to 20 over 3 units in its length. Yeah, this line segment qn equals to 20 over 3 units in its length. In the next step, we'll find out the length of this line segment MN. From the drawing it is very easy to see that Mn equals to Qn minus Qm. Repeat again. From the drawing it is very easy to see that Mn equals to Qn minus Qm. So Mn equals to Qn. Qn is 20 over 3 minus Qm. So in total we actually found out that Mn equals to 20 over 3 minus Qn. Again, Mn equals to 20 over 3 minus Qm. This line segment Mn equals to 20 over 3 minus Qm. Okay, so in the next step we complete this quarter circle to a circle. So we completed the quarter circle to a circle, and we'll extend line segment BO by straight line until it touches the circle. We define the touching point of the extended line segment BO with this circle as C. Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle, that is equal to 10 units. Why? Because the radius of the circle is exactly the same as the radius of the quarter circle. Why? Because we just completed the quarter circle to a circle. Therefore it is very clear that they have the same radius. Okay, so in the next step I will present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, rule number 14 is true in any circle. So in any circle, if we draw two chords A, B and C, D inside the circle from the common external point P, then the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So actually we have in the drawing this circle, and we have the common external point P. From the common external point P, we drew two chords inside the circle, chord AB and chord CD. Both those two chords are drawn from the common external point P. So in this drawing, the following equation is true, that PA times PB equals to PC times PB. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common external point N, from the common external point N, we have two chords inside this circle, chord MA and chord BC. So all the requirements of rule number 14 are met, and therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Okay, so I write it down. we get NB times NC equals to NM times NA. Repeat again. If we focus on the current external point N, according to rule number 14, we get that NB times NC equals to NM times NA. Okay, so NB is 10 over 3 times NC. What is the length of NC? NC is Cn. Cn equals to CO plus OP plus PB plus BN. So Cn in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. So it is 10 plus 5 plus 5, that is 20, plus Bn, that is 10 over 3. So in total Cn equals to 20 plus 10 over 3. Yeah. And see that is Cn equals to 20 plus 10 over 3, and it is equals to Nm. We just right now found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of Na? Na and An are the same. So An equals to AQ plus Qn. That is to say, An equals to AQ, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. So I found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to overcome factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression we have 70 divided by 3, and it is also equals to 20 over 3 minus Qm. Here we will multiply minus Qm by 3, and then we divide it by 3 in order to overcome factor with 20 over 3. And we get that in total, in the numerator we will have 20, and minus Qm times 3 is minus 3 Qm. So in total, in the numerator of this expression, we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to overcome factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the numerator of this equation, we have 50 divided by 3. See, so here on both sides of the equation we have in the denominator 3 times 3, that is 9. Therefore we will multiply this equation by 9 in order to cancel the denominator, that is 9. After we multiply this side of the equation by 9, we left only with 10 times 70. The other side of the equation, after we multiplied by 9, we left only with 20 minus 3 Qm times 50. Here we divide this equation by 10, and we get that 10 over 10 is 1, so in this side of the equation we left only with 70. That's equals to 20 minus 3 Qm times 50, and 50 over 10 is 5. So here we'll open the brackets on this side of the equation, and we get that 70 equals to 20 times 5 is 100, minus 3 Qm times 5 is minus 15 Qm. Here we subtract 70 from this equation, and we get that 70 minus 70 is 0, that equals to 100 minus 70 is 30, minus 15 qm. Here we read to this equation 15 qm, and we get that 15 qm equals to 30. It again. Actually found out that 15 qm equals to 30. Here we divide this equation by 15, and we get that qm equals to 30 over 15, that is 2. So 97 qm equals to 2 units in its length. So here, this 97 qm equals to 2 units in its length. So I write it down in the original drawing. This drawing that qm equals to 2 units. Our mission is to find out the length of this 97 am. That is equal to x according to what is given us the question. Here am equals to x. It again, we have to find out the length of 97 am that is equal to x. From the domain itself, it is very easy to see that am equals to aq plus qm. Again, am equals to aq plus qm. It again, am equals to aq plus qm. So am equals to aq, that is 10, plus qm, that is 2. So in total, am equals to 10 plus 2, that is 12. So actually found out that x, that is equals to am equals to 12 units in its length. And that is the answer to our question. Here, this 97 am is equal to x, is equals to 12 units in its length. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this 97 am is equal to x according to what is given as the question. So in the domain, we have this quarter circle, A or B is a quarter circle. Inside the quarter circle, we have this semicircle. In addition, we know that line segment AO equals to 10 units in its length, and our mission is to find out the length on this 97 am is equal to x according to what is given as the question. So first of all, we know that AOB is a quarter circle, therefore this angle AOB equals to 90 degrees, and also side AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But it is given as the question that A equals to 10, therefore OB must be also equal to 10 because it is also the radius of this quarter circle. OB is equal to 10, it is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter of this semicircle OB equals to 10. We define the center of this semicircle here as point P. Therefore, the radius OP must be equal to the diameter over 2. That is to say, the radius OP of this semicircle must be equal to 10 over 2, that is 5. Here, the radius PB is 5 of this semicircle. We define the point of tendency of tangent AM with this semicircle as Q. Then you join points P and Q together by a straight line. Point P is the center of the circle, point Q is the point on the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units in its length. Okay, then we extended side AM and side OB by a straight line until they touch each other. We define their touching point, this point, that is their touching point, is point N. By doing this construction, we actually created here the right big triangle, triangle AON. We define this angle as angle theta. We continue to focus on the right triangle AON. In the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, then focus on the great triangle QPN. In the great triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta according to the same logic as here, the right triangle AON. So the missing angle here must be equal to 90 degrees minus theta. Then we proved that the great triangle QPN is similar to the big right triangle AON. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so I can write down that angle theta equals to itself. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So I actually proved that all the three angles on the right big triangle AON are correspondingly equal to all the three angles of the great triangle QPN. Therefore, we proved actually that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5, and it is equals to AN. What is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the length of PN? PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN, and it is equals to ON. ON, what is the length of ON? ON equals to OP plus PB plus BN. That is to say, ON equals to OP, that is 5, plus PB, that is 5, plus BN. So ON equals to 5 plus 5, that is 10 plus BN. So in total, ON equals to 10 plus BN. Here, ON equals to 10 plus BN divided by QN. QN is the missing sign, so we leave it as it is. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is also equals to 10 plus BN over QN. Those two equations, those two sides are equal to each other, therefore we created equation number 1 from those two sides that are equal to each other. Those two sides are also equal to each other, therefore we created equation number 2 from those two sides that are equal to each other. So those are the two equations that we created from the long equation. Here we multiply this equation number 1 by 5 plus Bn, and found out that according to this equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this equation number 1, and found out that 2 times 5 is 10, plus 2 times Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, therefore 10 will get cancelled, and we left only with Qn, that is equals to 2 times Bn according to equation number 1. Here we have an equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn and found out that 2 times Qn equals to 10 plus Bn. But according to equation number 1, Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn. We did it here and found out that 2 times Qn is 2 times Bn. That's equal to 10 plus Bn. 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtract Bn from this equation number 2, and found out that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. We divided this equation by 3 and finally found out that Bn equals to 10 over 3 units in its length. Here, Bn equals to 10 over 3 units in its length. According to equation number 1, we have only found out that Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, we found out that Qn equals to 20 over 3 units in its length. Here, this line segment Qn equals to 20 over 3 units in its length. Then we completed this quarter circle to a circle, and we extended line segment BO by straight line until it touches the circle. We define the touching point of the extended line segment BO if this circle is C. Here, point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of the circle. The radius of the circle equals to 10 units in its length because it is exactly the same radius as the radius of the quarter circle. Okay. Then I presented to you a new rule and we implemented the new rule in our drawing. According to the new rule, this is rule number 14. Again, in any circle, if we draw two chords A, B, and C, D inside the circle from the common start point, point P, then the following equation is true: that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we have the common start point, point N. From the common start point, point N, we have two chords inside this circle, chord MA and chord BC. So all the requirements of rule number 14 are met, and therefore we can implement here rule number 14. According to rule number 14, we get that NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. And again, if you focus on the common start point, point N, according to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NM. What is the length of NM? NM equals to Qn minus Qm. Again, NM equals to Qn minus Qm. That is to say, NM equals to Qn, that is 20 over 3 minus Qm. So in total, NM equals to 20 over 3 minus Qm. Okay, so it is times Nm, and Nm is 20 over 3 minus Qm. Okay, and it is equals to Nm. What is the length of? We just right now found out that again Nm equals to 20 over 3 minus Qn. Again, Nm equals to 20 over 3 minus Qm times Na. What is the length of Na? Na is An, and An equals to Aq plus Qn. So An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. An equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. Here multiply 20 by 3 and then we divide it by 3 in order to overcome a factor with 10 over 3. So 20 times 3 is 60, and 60 plus 10 is 70. So in total, in the numerator of this expression, we have 70 divided by 3. And it is equals to 20 over 3 minus qm. We multiplied minus qm by 3, and then we divided by 3 in order to overcome a factor of 20 over 3. So in total, in the numerator of this expression, we have 20, and minus qm times 3 is minus qm. So in total, in the numerator of this expression, we have 20 minus 3 qm over 3 times 10 plus 20 over 3. Here we multiplied 10 by 3, and then we divided by 3 in order to have a common factor of 20 over 3. And found out that 10 times 3 is 30, and 30 plus 20 is 50. So in total, in the numerator of this expression, we have 50 divided by 3. So here, on both sides of the numerator of this expression, we have 3 times 3, that is 9. Therefore, we multiply this equation by 9 in order to cancel the numerator of 9. After cancel the numerator of 9, in this equation, we have to leave in this of the equation with 10 times 70, that is equals to 20 minus 3 qm times 50. Here we divided this equation by 10 and found out that 10 over 10 is 1, so we have to, in this of the equation, we have to leave 70, that is equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So in total, we found out that 70 equals to 20 minus 3 qm times 5. Here we open the brackets on this side of the equation and found out that 70 equals to 20 times 5 is 100, and minus 3 qm times 5 is minus 15 qm. So in conclusion, we found out that 70 equals to 100 minus 15 qm. Here we subtracted 70 from this equation and found out that 70 minus 70 is 0, and 100 minus 70 is 30, minus 3 qm, minus 15 qm. So in conclusion, we found out that 0 equals to 30 minus 15 qm. Here we added 15 qm to this equation, and finally found out that 15 qm equals to 30. Here we divided this equation by 15, and finally found out that qm equals to 2 units. Here, this line 7 qm equals to 2 units in its length. Again, our mission is to find out the length of this line 7 am that is equal to x. We have to find out the length of am that is equal to x according to what is given in the equation. For the drawing, it is very easy to see that am equals to aq plus qm. Again, am equals to aq plus qm. So, am equals to aq plus qm. aq is 10 and qm is 2. Again, aq is 10 and qm is 2. So in total, am equals to 10 plus 2, that is 12. So we actually found out that the length of this line 7 am is equal to x. It is equals to 12 units in its length. Okay, thank you very much.